चलो 6 बजे So in the previous class, we have already covered this position, path length, and displacement. Let's recapitulate whatever we have done. So position means, the word position means position of an object with respect to some reference frame of surrounding, yes, or time. Mhm. So position, reference frame and set of axes is needed. Reference frame and set of axes is needed for to locate the position of any object. Reference frame is required, set of axis is required. Only then we can locate the position. Yes. So we need a reference frame to locate the position. Next is path length. Path length is the actual distance covered by an object, is the path length. And next, third one is displacement. Displacement is the yes, it's shortest distance between the initial and final position is displacement. Yes, this we had covered in the previous class. Now, distance is the actual path traversed and displacement is the shortest distance. This we know. Shortest distance is the straight line distance. If we say that initial position of the object is A and it goes through the dotted path and reaches point B, then shortest distance between A and B is the straight line distance. Yes, it is a displacement. So we have a question based on this. Position of a particle moving along a straight line is given as x equals to t square minus 4t meters. Find the displacement and distance covered between t is equal to 0 and t is equal to 3 seconds. Do this. Karo. So x is t square minus 4t. So at t is equal to 0, we'll find the value of x first. X is equal to, let's say x naught. It is 0 square minus 4 into 0. Answer is 0. At t is equal to 3. X3. Okay, put the value of t as 3. 3 square minus 4 into 3. What will you get? 9 minus 12. Answer is minus 3. So what is the displacement and the distance? Object is moving in a straight line. Why is this distance negative? Why is this value of x negative? X-axis negative side. XT graphs and look at these graphs. So for a stationary object, if the object is stationary, if the object is at rest, then its position will not change with time. Then which graph shows the position of the object is not moving? A. For uniform motion? B. See, for uniform motion, we have two different graphs here, B and C both. Both the graphs, you can see we have straight line. What is the difference? वो तो I can see नीचे से ऊपर से नीचे, but what else? Or we can say negative or positive, something like this. Huh? So this graph B represents positive velocity and graph C represents negative velocity. Okay, B represents positive velocity and C represents negative velocity. Next is non-uniform motion. If we have a non-uniform motion, then position time graph is a curved line. Yes? Please close it. Position time graph is a curved line. So D and D represent non-uniform motion, but how are they different? How are they different? Yes. So in the first case, you can see in graph D, velocity is increasing with time, while in graph E, velocity is decreasing with time. Yes. In graph D, it is increasing, and graph E, it is decreasing with time. Okay, we have one more graph, graph F. Now, tell me the difference between graph B and graph F.
स्पीड इनिशियल में 0 थी, उसके बाद स्पीड
वो दोनों में आपका initially object is at some distance from the origin in both B and F. What is the difference between B and F? One graph is more inclined than the other. In which graph we have greater angle of theta? Which has greater slope? And from distance time graph, when we find slope, what do we get? It is position time graph From position time graph, when we find slope, what do we get? Speed or velocity, that depends. If we have distance time, we find speed, we can find speed. And if we have displacement time, then we can find velocity. Yes? So slope gives the speed or velocity. So which graph represents greater speed or velocity? V or F?
B.
V represents greater velocity because its slope is greater. नहीं आया? नहीं आया ना? तो हाँ क्यों गया? किसको नहीं आया और अब नहीं? तो पता होता है बेटा. मैंने यहाँ बोला ना, फिर यहाँ बोला. पता है 2 बच्चों को नहीं आया इधर. एक्सप्लेन करना बेटा फ्रेंड को अपने. देखो स्लोप का मतलब होता है कि अगर हमारे पास पोजीशन टाइम ग्राफ है तो हम वी कैन फाइंड 2 थिंग्स फ्रॉम द ग्राफ. एक तो हम फाइंड कर सकते हैं स्लोप और एक एरिया अंडर कर्व. अगर y और x एक्सिस है ना, x एक्सिस में और y एक्सिस में हमें गिवन होता है, जैसे यहाँ पे y में डिस्टेंस है और x में टाइम है. दोनों को डिवाइड करके क्या आता है? डिस्टेंस और टाइम को डिवाइड करके क्या आएगा? स्पीड आएगा ना. तो इसका मतलब जो स्लोप हम निकालेंगे तो वो स्पीड आएगी. स्लोप मैंने सिखाया था ना, y2 माइनस y1 अपॉन x2 माइनस x1, है ना. m इज इक्वल टू tan थीटा इज इक्वल टू y2 माइनस y1 अपॉन x2 माइनस x1. स्टार्ट ही हमने फिजिक्स ऐसे की, है ना. याद है या भूल गया सब कुछ? ठीक है. तो ग्रेटर स्लोप जिसकी होगी उसकी वेलोसिटी या स्पीड जो भी है वो ज्यादा होगी. नाउ लुक एट दिस ग्राफ. So we have, different situations in one graph. So look at this line now. We have a blue line and this green line. Now they both represent uniform motion. Both the lines represent uniform motion, but both have the steady speed, means they are moving with constant speed. Equal distance in equal intervals of time. Yes, it's uniform motion. Object is covering equal distance in equal intervals of time. So both the graphs represent constant speed, but this green colored graph, it has greater speed because it has greater slope. Greater slope means more speed. So if we compare green line and blue line, then we can see that blue line is more inclined towards x-axis. So angle that it makes with x-axis is smaller as compared to the green line angle. Okay. So blue line has less slope, therefore less speed, and green line has more slope, greater value of theta, so it has more speed. स्लोप किसकी ज्यादा होगी कि उस एक्सिस से एंगल कितना बना रहा है, इसका एंगल ज्यादा होगा उसकी स्लोप ज्यादा होगी और वो उतनी ही ज्यादा वैल्यू आएगी. डिस्टेंस टाइम ग्राफ की स्लोप से क्या मिलता है? स्पीड मिलता है, क्योंकि डिस्टेंस और टाइम को डिवाइड करके स्पीड आता है. ठीक है. नाउ दिस लाइन which is parallel to time axis, look at the cursor movement. When you see, at 5 seconds distance is 40 meters, 6 seconds again the same distance, 7 seconds we have the same distance, 8 same distance, 9 same distance. What does it mean? What does this indicate? Object is not moving at all, it is at rest. Okay. And this line again, it is uniform, but it shows, yes, and this curved line, this is acceleration. डिस्टेंस नहीं है ये, इसका डायरेक्शन ऑफ मोशन चेंज हो गया. यहां देखो, दिस इज एक्सेलरेशन मींस स्पीड इज इंक्रीजिंग, एंड देन deceleration means speed is decreasing, and here it is stopped. Okay. Slope of xt graph gives the velocity. Now you have to find velocity from A to B, B to C, and C to D. How will you find velocity? Do you know how to find it? कैसे find करोगे? How will you find velocity? Slope of displacement time graph gives the velocity. Yes, slope gives the velocity. So for this, we'll consider 2 different points. है ना? Let this point be x1, y1, and this is your x2, y2. Then slope is y2 minus y1 upon x2 minus x1. and slope of displacement time graph gives the velocity. Because we are finding slope of displacement time graph, so the value that we'll get is of velocity. Okay. Now do this. Karo, karo. Consider 2 points here. See, this is 2, na? X-axis is, on x-axis we have 2, on y-axis we have 0. And if we consider this point, on x-axis we have 5, and on y-axis we have 3. So we can find slope, yes. So velocity we have to find out, right? Velocity is slope of xt graph. So it's y2 minus y1 upon x2 minus x1. So this is x2, y2. This is y2, x2, x1, y1. Now use the formula y2 minus y1. 3 minus 0 upon x2 minus x1 is 5 minus 2. So you'll get Hanji, 1 meter per second. Second, B to C. See, this line is parallel to time axis, so it is clear that object is not moving at all. Yes, but because we need to find velocity using, we have to find the slope. Let's find the slope. This is 5, 3. So we can locate the coordinates at 7, 3. So it's 3 minus 3 upon 7 minus 5. Answer is 0 upon 2. Velocity will be 0 meter per second. Third case, C to D. We know the coordinates of C. What are the coordinates of D? 10, 0. Okay, so find velocity. Y2 minus y1, 0 minus 3 upon x2 minus x1, 10 minus 7. So what will you get? It's minus 3 upon 3. Answer is minus 1 meter per second. How speed and velocity are different? Speed is the rate at which an object covers a certain distance in unit time. On the other hand, velocity is the rate at which an object changes its position in certain direction. Average speed will continue to count even if the object changes direction. On the other hand, velocity of the object changes with a change in direction. Therefore, the object must follow one direction. Speed is a scalar quantity. On the other hand, velocity is a vector quantity. Yeah, right? Speed can be
Can't be negative.
Can never be negative or 0. It is positive. On the other hand, velocity can be 0, negative or positive. Yes. So next we have average speed and average velocity. So what is average speed? This we have covered in previous class, right? Total distance upon total time. And average velocity is total displacement upon total time taken. Yes. Average speed is the total path length traveled divided by total time taken. And on the other hand, average velocity is the change in position or displacement divided by the time intervals in which the displacement occurs. Average speed does not tell us in what direction the object is moving. It is a scalar quantity. Because it is a scalar quantity, so direction का तो कहीं से कोई link ही नहीं है ना. On the other hand, average velocity is a vector quantity. It is this total displacement upon total time. Average speed is always positive because distance covered is always positive. Distance covered can never be negative. While average velocity can be positive, negative, or 0. See, if the object is moving in a straight line, then distance and displacement are same. Path length is equal to displacement. So in this particular situation where path length and displacement are equal, then average speed and average velocities are also equal. Okay. If the object is moving in a straight line, then path length and displacement are equal. So is the speed and velocity, average speed and average velocity. Should I move to the next slide? Find the. A bird flies towards east at 10 meter per second for 100 meter. It then turns around and flies at 20 meter per second for 15 seconds. Find its average speed and its average velocity. So, bird is flying towards east direction with a speed velocity of 10 meter per second for 100 meter. Distance is given, it is 100 meter. It then turns around and turns around. It goes towards west with a speed of 20 meter per second for 15 seconds. Find its average speed and average velocity. Okay. So we need to find total distance and total time taken first. So what is, see, when it is moving with a velocity 20 meter per second, 20 meter per second and time is given, it is 15 seconds. You can find the distance. है ना? Let's take this as V1 and this as S1 and this as T2 and this as V2. Okay. So we can find S2. S2 is V2 into T2. V2 is 20 meter per second, time is 15 seconds. What will you get? 300 meter. And we can find T1 here. T1 is V1 by S1. It is 10 upon S1 by V1. Sorry. T1 is S1 by V1. So it's 100 upon 10. So time is 10 seconds. Now we have to find average speed. Average speed is, yes, total path length divided by total time taken. Properly likho beta step by step. You're not writing steps, I guess. Total path length is S1 plus S2 and total time taken is T1 plus T2. Put the values. S1 is 100, S2 is 300, T1 is 10, T2 is 15. What will you get? 400 upon 25, 16 meter per second. कैसे निकालें? Average velocity. First find displacement.
200 meter का जो displacement है.
Which direction?
West.
वापस की साइड. तो फिर नेगेटिव होगा पॉजिटिव होगा.
Negative होगा. Negative 8 meter per second आ रहा है उसका कि total time लिख दे उसकी 25 है.
Total displacement it's 100 and then it goes back, it turns back and covers a distance of 300. So this is 300 minus 100 we can say, or 100 minus 300 भी ले सकते हो आप. ठीक है, if you are considering the direction or if you are considering your east direction as positive or west as negative, it's your choice. But how are you taking the direction? So let's take the magnitude only, no, don't take the direction. Okay, so it's 200 and time is again the same. It's 25.
8 meter per second.
8 meter per second is the average velocity.
Minus or plus?
You can see, it's your choice. If you're considering this direction as positive, then this is your negative direction. If you're choosing this direction as negative, then it is minus. Okay. तो ये assumption आपके ऊपर है कि कौन सी direction आप positive ले रहे हो, कौन सी direction आप negative ले रहे हो. In the previous class, we haven't covered this. Okay. So instantaneous speed or instantaneous velocity means instantaneous. The word instantaneous is there. At an instant.
At that particular moment.
At that particular moment, at a point of time. Okay. For a very short duration, for a very small interval, for delta t tends to 0. Small interval means negligible time, right? So if we consider a delta t tends to 0, then it's negligible time. So instantaneous velocity describes how fast an object is moving at different instants of time in a given time interval. It is also defined as average velocity for an infinitely small time interval. Okay. See, average velocity, how do we find? Delta x by delta t is average velocity. And if we limit this to 0, if we limit delta t tends to 0, limit means delta t is approaching 0. It's so small, it's very small, it is approaching 0. Then we can write this as dx by dt. Dx by dt is the differential term here that we have already covered in mathematical physics. Yes. A limit stands for the operation. It it signifies that delta t is approaching 0. It is very small, infinitesimally small. and dx by dt is differential coefficient, rate of change of position with respect to time at any instant. It dx by dt. Dx means change in position. Dt is time interval. So rate of change of position with time. Whenever we divide time with any physical quantity, we say rate of change of. Right? For acceleration also, v minus u by t, we say rate of change of velocity. So if we divide change in position with time, we say rate of change of position. And if we divide momentum with time, dp by dt, we say rate of change of momentum with time. This is how we say. Yes. अब तो हमें पता लग गया ना क्या होता है रेट ऑफ चेंज ऑफ, मतलब स्पीड, जिस स्पीड से वो चेंज हो रहा है. So instantaneous speed is the magnitude of velocity. Instantaneous speed at an instant is equal to the magnitude of instantaneous velocity at that instant. ठीक है. So we have a graph here. देखो इसमें क्या है. Please stop writing and look at the screen. This is very important. Concept clear यही होगा. Who can explain this graph to me? What does this graph signify? By looking at this graph, what comes in your mind? क्या समझ आता है कि हाँ इस ग्राफ में हम शायद ये एक्सप्लेन करना चाहते हैं. We have drawn, we have taken points here, P1, P2, Q1, Q2. We have joined the points and we are considering intervals like something like this, right? So what are we trying to explain through this graph? Please.
P1 और P2 है तो shortest mark कर रहा है उसके अंदर जो instant speed 3 सेकंड के बीच में जो start travel कर रहा है P1 से P2
P1 से P2 3 seconds में हाँ
travel कर रहा है उसके हम shortest distance के अंदर straight line बना दी और कोई हमने Q1 और P2 के साथ करा जो 4 सेकंड
तो क्या समझ आ रहा है आपको इसमें से? ये इंस्टेंटेनियस वेलोसिटी वाली स्लाइड में इस ग्राफ का क्या मतलब है? ये क्यों है ये ग्राफ यहाँ पे? कोई और? हाँ जी ठीक है, बहुत बढ़िया. So why are we comparing this, you know, P1, P2, Q1, Q2? Why are we taking these points here? Mudit? No idea? Get idea. हाँ जी आपने कभी ना कभी तो पता लग ही जाएगा. हाँ जी इधर अनुष्का, हर्ष, विनम्र. यहाँ बेटा कहाँ देखोगे, बाहर जाओगे? इधर देखो 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 देखो
उस पोजीशन पे उस ऑब्जेक्ट की क्या वेलोसिटी रही होगी,
उस पोजीशन पे उस ऑब्जेक्ट की क्या वेलोसिटी रही होगी. ओके देखो हम क्या ले रहे हैं, हम आपको जब इंस्टेंटेनियस वेलोसिटी का जब फॉर्मूला बता रहे हैं, देन वी आर सेइंग दैट डेल्टा टी अप्रोचेस 0. तो हम डेल्टा टी को जब कम 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 करते जा रहे हैं, है ना. अब अगर आप P1 P2 देखते हो तो P1 P2 में टाइम इंटरवल जो है आपका वो 3 सेकेंड्स का है. तो यू सी द डिफरेंस, है ना. यू सी द चेंज इन पोजीशन विद टाइम, राइट. बट एज यू डिक्रीज द टाइम इंटरवल, है ना, तो ये धीरे धीरे यू विल सी कि ये धीरे धीरे ना इट कम्स क्लोजर एंड क्लोजर. दीज पॉइंट्स आर कमिंग क्लोजर. वेयर इज माय कर्सर? यस हियर इट इज. You know, these points are coming closer. So if you choose you know, point here, somewhere here, so a stage will reach when the 2 points will coincide. Then a delta t is approaching 0. At that point delta t is approaching 0 and their velocity is nearly
0.
Not 0, it is constant. Displacement, where their change position is not yes yes. No, displacement is not 0 there.
टाइम पे हो जाएगा.
डेल्टा टी 0 हो जाएगा. जैसे जैसे ये देखो P1 P2 पे थे तो दूर दूर था ना पॉइंट, और जैसे जैसे पास आते जा रहे हैं तो ये आप देखोगे ना, तो स्टेज विल रीच when we'll choose the 2 points, then they'll nearly coincide and their delta t is 0 or tends to 0, we can say, approaching 0 we can say, or negligibly small we can say. Now tell me, what is this? Average velocity लिखा हुआ, entire trip का it's 3.5 meter per second towards right, and instantaneous velocity is changing now. When this man stops, instantaneous velocity becomes 0, then 6, then 4. Sometimes this man is, you know, moving faster, and sometimes this man is moving slower, and sometimes it just this man just
पहले
stops.
सेकंड में 6 मीटर पर सेकंड की स्पीड से चला है, ठीक है,
हम्म,
फिर दूसरा सेकंड है 0 4 मीटर पर सेकंड से चला है, कम टाइम में ज्यादा
तो ये क्या समझ आ रहा है कि इंस्टेंटेनियस वेलोसिटी में वी आर जस्ट फोकसिंग ऑन द speed at that particular instant only. At that point of time, what is the speed? What is the velocity? At that point of time, what is the velocity? हमारा focus उस पे है. We are not bothering about the average velocity कि हाँ देखो कभी रुका, कभी fast हो गया, कभी slow हो गया, right? It's going like this ना. तो जब instantaneous velocity में it is giving the velocity at that point of time only. While average velocity is the velocity of the entire trip. Average velocity. On an average कि 1 सेकंड में 3.5 मीटर डिस्टेंस कवर किया. Speedometer of a car measures instantaneous speed.
मान लो टोटल 14 सेकंड ट्रैवल करा है.
Yes, next we have a question. No, we haven't done this. See, we had found out the distance and displacement for this question. Now we have to find instantaneous speed at t equals to 3 seconds. X is given and we have to find instantaneous speed. Please do this question now. Have you done?
Yes.
Do this question, write in proper way all the steps. So t square minus 4t we have. Yes. So first, see, we have to find instantaneous speed at t equals to 3 seconds. Find dx by dt. Differentiate it with respect to t. थोड़ा सा पेन चलाओ.
हम पूरा करें.
2t minus 4 you will get. This is instantaneous velocity. And we have to find instantaneous speed at t equals to 3 seconds.
तो हो गया.
It's 6 minus 4. Answer is 2 meter per second. इसको differentiation नहीं आता? नहीं आता? See, when we differentiate x raised to the power n, it's nx n minus 1. So if we have, कल बताया था मैंने, if we have t square, then we have n, for n we have 2 na? So we'll write 2t 2 minus 1. And when we differentiate a constant, then we get 0. Okay, so we have simply use these relations and formulas and solve this. Next topic is acceleration. So what is acceleration? Accelerator we have in cars. We press the accelerator and speed of the car increases. When we release the accelerator, then speed of car decreases. So what is acceleration? Yes, it's rate of change of velocity with respect to time. How velocity changes? See, if initial velocity of the object is u and it attains velocity v in time t, then we write acceleration as. बताओ.
V minus V.
Yes, it's v minus u by t. Final velocity minus initial velocity upon time taken. So acceleration is v minus u upon t. What is the unit of velocity?
Meter per second.
Unit of time. Acceleration की unit meter per second square होती है, right? It is a vector quantity. And what is retardation or deceleration?
Negative acceleration.
Negative acceleration. When is acceleration negative?
तो गाइड यू इज
When car stops. Yes. When final velocity is smaller than initial velocity. If the velocity of the object decreases with time, then it is retarding. Okay. And if an object is moving with uniform motion, then its speed is constant and there will be no acceleration. Acceleration is 0. So now we have a question. Starting from a stationary position, Rahul pedals his bicycle to attain a velocity of 6 meters per second in 30 seconds. Then he applies brakes such that the velocity of the bicycle comes down to 4 meters per second in the next 5 seconds. Calculate the acceleration of the bicycle in both the cases. Karo. Starting from the stationary position means starting from the stationary position initially. Yes, so initially u is 0. Rahul pedals his bicycle to attain a velocity of 6 meters per second. Then velocity becomes 6 meters per second and time taken is 30 seconds. Let t is equal to 30 seconds. And after this, he applies brakes. When he'll apply brake, then bicycle will stop. Or the velocity of the bicycle will decrease. Okay, so when he applies brakes, then velocity of the bicycle comes down to 4 meter per second in the next 5 seconds. Let t dash as 5 second. So we have to find the acceleration in both the cases. This is case 1 and this is case 2. Tell me.
1/5 meter per second,
Mhm.
whereas or minus 2.5 meter per second.
Yes, acceleration is v minus u by t. V is 6 minus 0 upon time is 30 seconds. So it's 1/5. This is what you're getting, no? 1/5 or 0.2 meter per second square. Second case. In the second case, our final velocity is v dash and initial velocity for the second case is v and time is t dash. Okay, so we'll simply put the values here. It's 4 minus 6 upon 5. So it's minus 2/5, or we can say it's minus 0.4 meter per second square.
10 पे time पे तभी वो
7-10 पे भी थी।
तो 8-10
आप पहले से नहीं पढ़ा कि दस
बेटा मैं वेट करेगी ना
Attendance
आपका। आपके बिना कैसे मैं क्लास
से?
थोड़ा टाइम पे आओ, टाइम पे शुरू कर लेंगे। चलो चलो नेक्स्ट एवरेज एक्सेलरेशन। As we have average speed, average velocity, in the same way we have average acceleration. क्या होता है average acceleration? Change in velocity divided by time interval during which the change occurs. So we write average acceleration as delta v by delta t. It's v2 minus v1 upon t2 minus t1. Change in velocity upon time required for change. So we'll simply find the slope of VT graph to get average acceleration. Okay. And we have two more terms here, uniform acceleration and non-uniform acceleration. So when is acceleration said to be uniform? The word uniform means constant. If we have equal change in velocity in equal intervals of time, then acceleration is uniform. And non-uniform acceleration means acceleration is not uniform, acceleration is not constant, acceleration is changing. So when we have unequal change in velocity in equal intervals of time. Because acceleration क्या होता है? It's v minus u by t. ना? If we have equal by equal, then it is uniform. If we have unequal by equal or equal by unequal, then it is non-uniform. This is how we do, na? Even for displacement upon time, we write equal displacement in equal time, then uniform velocity. Unequal displacement in equal time, non-uniform velocity. So in acceleration, we have v minus u upon t. Yes? So equal change in velocity in equal time, uniform acceleration. Unequal change in velocity in equal time, unequal change in velocity in equal time, non-uniform. ठीक है? Instantaneous acceleration. What is instantaneous acceleration? Acceleration. How do we write the expression? We know it's
dv upon
it's dv upon dt, or in terms of position, if I want to write, then
dx upon नहीं यही नहीं है एक सेकंड अब याद करने दो
I'll tell you, don't worry. The instantaneous acceleration, if an object is moving with variable acceleration. Variable acceleration means non-uniform. If an object is moving with variable acceleration means non-uniform, then the acceleration of the object at any instant is called instantaneous acceleration. It may also be defined as limiting value of average acceleration over an interval of time which approaches to 0. So we limit the average acceleration. How do we find average acceleration? Delta v by delta t. So if delta t tends to 0, then it becomes delta v by delta t hota hai na acceleration, average acceleration. So if delta t tends to 0, then it becomes dv by dt. This we had done for instantaneous velocity. And what is v? V is dx by dt, a is dv by dt. So we can write a in terms of x, d square x by dt square. जो बाद में आए हैं मैथमेटिकल फिजिक्स होने के, उन्हें कुछ अलग अलग लग रहा होगा।
चेन रूल लगा
कर लेगा।
चेन रूल लगा रहे हैं।
वो कुछ और डिफरेंशिएशन होगा कुछ। dx by dt is v ना, dx by dt is v।
होता है। हाँ।
ओके ओके, इक्वेशन ऑफ मोशन में बीच में से पार्ट उठाया।
अरे वो मेरे को एकदम से याद आया, इक्वल्स टू वीडीएक्स अपॉन डीटी लिखा
मैंने कहा ये
है
कहाँ से?
किसी कॉपी में कभी तो।
वो आपने किया कैलकुलस, ऑब्जेक्ट इज मूविंग विद कांस्टेंट वेलोसिटी, देन vt ग्राफ इज पैरेलल टू टाइम एक्सिस, है ना? If the object is moving with constant velocity, then vt graph is parallel to time axis, or here acceleration is
यूनिफॉर्म
beta constant velocity. There is no change in velocity, no? So acceleration is zero. If the object is moving with constant velocity in this graph A, then it is zero acceleration. Second graph represents uniform acceleration. Uniform acceleration. We have equal change in velocity in equal time here. If it is displacement time graph, then it is uniform velocity, but it is not displacement time, it is velocity time, na? So it is uniform acceleration. Acceleration is increasing or decreasing? Increasing, yes. Next, third,
रिटार्डेशन
yes, it's uniform retardation. It's negative acceleration, we can say. Third one, B is positive acceleration and C is negative acceleration. Any doubt in these graphs? First three graphs में थोड़ा सा भी doubt हो तो you can ask me right now. ठीक है? Okay, now tell me graph D, about graph D. Initially, object is moving with some velocity. Its initial velocity is not zero. See, in B and, in this B and C. In B and C, initially object is at rest. है ना?
यस
Initially object is at rest in B and C. In C also you'll find, at point A, velocity is zero. And here also initially at point zero, velocity is zero at O. Please wait for a minute. ठीक है? So in the, in this D, you will see that initially object is moving, na? And it is uniformly accelerating. Again, we have positive acceleration only. B and D look similar. The only difference is in B, object is at rest initially, and in D, object is initially moving with some velocity. But in both the cases, we have positive acceleration and acceleration is uniform. Next is non-uniform acceleration, E. E is the curved line. Na? Curved line means we have unequal change in velocity in equal time. It's variable acceleration. It shows non-uniform or variable acceleration. And the last one, see, this is increasing acceleration. And if we have graph like, inverted graph like that, then that is decreasing acceleration. And in the last one, F, first velocity, it's increasing uniform. Yes, it's uniform acceleration. Then we have zero acceleration. And then we have uniform retardation. So uniform acceleration, zero acceleration, and uniform retardation. Any doubt in these graphs? Now look at this. So this blue line represents acceleration is constant. And then we have C, velocity is 20 meter per second. Yes, zero acceleration means बिल्कुल भी उसकी velocity change हो ही नहीं रही है. From 20 seconds, t is equal to 20 to t is equal to 40. Object is moving with a constant velocity of 20 meter per second only, though its acceleration is zero at this time.
40 से 50 का ना 10 डिक्रीज होता है.
Yes, 40 to 50 में 10 decrease हो गया, so it's negative acceleration. 50 to 90 में it's increasing acceleration. Yes, it's non-uniform. Yes. अब आपको मतलब अच्छे से आ गया. जब आप बच्चे बोलने ना दे, तो ये आ गया मतलब. तो उसको आगे prove कर दो.
छुट्टी कर दीजिए.
Okay, this is the last question. उसके बाद पक्का छुट्टी. ठीक है, but we haven't completed graph as of now, as yet. इतने सारे, इतना सा रह गया, बस जरा सा रह गया, कर लो ना. हाँ,
मैम कल आप ये थोड़ी कराओगे, ये चैप्टर थोड़ी कराओगे
कल यूनिट से
हाँ कल तो
मतलब
पुराना
हम
है।
थोड़ा जो चैप्टर है चैप्टर वन
जिसने नहीं किया हुआ मुदित, आपको आता है components? Vectors we are not doing tomorrow, we are doing dimensions tomorrow. अगर डायमेंशंस के लिए किसी को डाउट है तो हम कल क्लास कंडक्ट कर लेते हैं, फिर नहीं करें कल का दिन.
नहीं है ना कल मतलब
एक्सेलरेट वेक्टर्स के लिए फिर हमारी इस बात होना ही है, वेक्टर्स कंप्लीट देन यू कैन. ओके, फाइंड द एक्सेलरेशन एंड डिस्प्लेसमेंट यूजिंग VT ग्राफ. So acceleration we need to find separately na, for O to A, A to B and B to C we have different values of acceleration, right? So first find for O to A. O to A, how will you find acceleration? It's slope of VT graph. So for O to A, locate the points. It's 0, 0. And this point is A is 10 and 20. And how do we find slope? It's y2 minus y1 upon x2 minus x1, right? So 20 minus 0 upon 10 minus 0, and answer is 2 meter per second square. इसको समझ नहीं आया. A to B, we are finding acceleration first, na? Right, acceleration here. Yes, it's 0 because coordinates of this point is 20, 30 and 20. So A is 20 minus 20 divided by 30 minus 10. So 0 by 20, answer is, we are not writing both it. You done? 0 meter per second square. From B to C, acceleration is, locate the coordinates again. It's 40, 0. So it's 0 minus 20 divided by 40 minus 30. So minus 20 upon 10. Answer is minus 2 meter per second square. Shows uniform retardation. Huh? Now let's find displacement. Displacement is, how do we find displacement? Area under VT graph. And area under VT graph is, what is this area? This is the area of, this is a trapezium. We have this trapezium. So what is, how do we find area of trapezium? Yes, half into sum of parallel sides AB plus OC into distance between the parallel sides. Distance between the parallel sides, let's take this point as D. So distance between the parallel sides is AD, है ना? Half AB is 30 minus 20, na? It's 30 and minus 10. 30 minus 10, it's 20. And OC is 40. OC is 40 and AD is 20. So distance covered is 600 meters. Sorry, displacement. Displacement is 600 meters. When we draw XT graph, we usually draw for velocity, constant velocity, variable velocity. We draw XT graph for object at rest, for increasing speed, for decreasing speed, right? When we draw distance time graph, we always talk about speed. We do not talk about acceleration. And when we draw velocity time graph, we say that yes, it is moving with constant velocity, uniformly accelerating, non-uniformly accelerating, decelerating, retarding. Yes, this is how we speak. What if I want to relate position and acceleration? And how are they related? You have done 3 equations of motion, right? So what are those 3 equations? S is equal to ut plus half at square. V square minus u square is equal to 2as. V is equal to u plus at is the first equation. Yes, you know all the 3 equations. So if you look, just focus on second equation of motion. In second equation of motion, if we assume the object to be at rest initially, then we have S is equal to ut plus half at square. And if we are assuming the object to be at rest, its initial velocity is 0. Then we can write s as half at square. So if we assume acceleration to be uniform, if we assume acceleration to be uniform means if we assume that acceleration is not changing, if we assume that acceleration is constant, then s is equal to half at square. May we have just one factor on which displacement depends, and that time. That is time. Displacement is directly proportional to square of time if we put acceleration as constant. If we assume acceleration as constant, if we assume that acceleration is not changing with time, है ना? तो s आपका half at square है. Half is a number. It is a constant. If the object is uniformly accelerating, then a is also a constant. Then we are left with just t square on which our displacement depends on. So it's s proportional to t square graph. Displacement proportional to square of time graph. Okay. So what you are seeing here on the screen is displacement proportional to square time graph. It is not direct v proportional to t like thing. When we have something like v proportional to t or x proportional to t, then we draw a straight line. Yes, but here we have x proportional to square of time. So this is how we draw the graphs. So for positive acceleration, if we have acceleration positive, then graph is like this. If we have acceleration negative, then graph is like this. For negative acceleration, it is going down. And if acceleration is 0, acceleration is 0 means object is not accelerating at all. Object is moving with constant velocity. And if the object is moving with constant velocity, then it is covering equal displacement in equal intervals of time. And if there is equal displacement in equal time, then we get a straight line. Okay, then we get a straight line. This is what we are getting here in the third graph. Any doubt here in these graphs? All graphs are clear. No doubts nowhere. Okay, should I move to the next slide? Great. Now we have these graphs. Oh my God, we have 9 graphs here on one page. XT, VT, and AT graphs. So for stationary object, if the object is stationary, if the object is at rest, if the object is not moving at all, then we can draw XT graph like this, parallel to time axis. Our XT graph is parallel to time axis. For VT and AT, we cannot draw. Because if the object is at rest, we can discuss only the distance. We can talk about the displacement of the object or the distance traveled by the object. It is constant. It is at a constant distance. It is not moving, right? But we cannot talk about velocity because it is not moving. Its velocity is 0. And since it is not moving, velocity is 0. So it is, how would he accelerate? He cannot accelerate because its velocity is 0. Yes. Now let's move to another section of uniform motion. If the object is moving with uniform motion, then displacement time graph is a straight line inclined to time axis. Object is covering equal displacement in equal intervals of time. So we get a line inclined to time axis. If the object is moving with uniform motion, then it is moving with constant velocity. And if we want to draw VT graph for constant velocity, then we are assuming velocity to be constant at every point of time. So at each and every time interval, we have the same value of velocity. So we'll get a line parallel to time axis. So we're getting this second graph here. You can see. Look at the board. Any doubt? आपको पता है मैं कौन से ग्राफ पे पहुंच गई हूँ? Graph number 5. It's graph number 5. Yes. And uniform motion के लिए can we draw acceleration time graph? No, we cannot draw because object is not accelerating. It is moving with constant velocity. So उसका acceleration है ही नहीं ना. It is 0. We won't draw. We cannot draw. Now let's consider the third case where the object is moving with constant acceleration. We are assuming acceleration to be constant. That's why we have taken x proportional to t square. Displacement is proportional to square of time. So for positive acceleration, we draw a graph like this. It goes like this. xt graph for positive acceleration, for negative acceleration, it goes like this. For uniform motion, for uniform acceleration, how do we draw VT graph? It's a line inclined to time axis. Acceleration है बेटा. Equal change in velocity in equal intervals of time. हर बार जो velocity में change आ रहा है, वो equal amount से आ रहा है, equal time में. तो हर बार velocity तो change हो रही है 10 से 20, 20 to 30, 30 to 40. It is changing. ठीक है 1, 2, 3, 1 पे 10, 2 पे 20, 3 पे 30. It is going like this. So we will get graph like that. Straight line inclined to time axis. If we want to draw acceleration time graph for the same case, constant acceleration, then we are saying that object is moving with uniform acceleration, with constant acceleration. Then acceleration is constant at every point of time. At each and every point of time, we have the same value of acceleration. So we can draw a line parallel to time axis. AT graph is parallel to time axis for constant acceleration. Any doubt in all these line graphs? We have simply compared different cases on XT, VT, and AT graphs. Okay, I hope this part is clear and we can move to the next slide. Motion with constant acceleration समझा दें. Sorry? XT graph, हाँ देखो मैं बताती हूँ आपको. अगर हम ये मान के चल रहे हैं, because we know x is equal to ut plus half at square. Yes. If we are assuming initial velocity, we are saying that object was at rest initially. If we are assuming that u is 0, then we can say that x is equal to half at square. And we are considering the case where the object was at rest initially. If the acceleration is uniform, if the acceleration is constant acceleration, so it depends on half a and t square. Half is a constant, a is also a constant. So x, there is only one variable no? On which this x depends on, that's t square. So x is proportional to t square. So when we draw the xt graph, we draw like this. Because it is proportional to t square, not t, so we cannot get a straight line. If it is proportional to t, only then we get a straight line. It is proportional to square of time, so we get a curved line. Okay? And in VT graph, because we know that acceleration is equal to v minus u upon t. So we have equal change in velocity in equal intervals of time. And we're keeping the acceleration constant, the same. Its value is same everywhere. No? So we'll get this line. Line inclined to time axis. And for constant acceleration, we are assuming that acceleration is 2 meter per second square every time. That at time t is equal to 0, it's 2 meter per second square. At time t is equal to 1 second, it is the same. At time t is equal to 2 seconds, it is again the same value. So we are getting a constant every time. In this case, we'll get a line parallel to time axis. Anything else? सिर्फ मेरी हाँ में हाँ नहीं मिलानी है. अगर थोड़ा सा भी डाउट लग रहा है आपको कि नहीं, इतना सा भी अगर मन में थोड़ा सा भी जरा सा भी डाउट है, उस डाउट को रखना नहीं है. तो मैं बोलती हूँ ना, मैं क्या बोलती हूँ कि अगर डाउट को रखोगे तो वायरस के जैसे मल्टीप्लाई हो जाएगा. यूनिफॉर्म मोशन का जो एक्सटी ग्राफ है, इसमें एक्स जो है वो स्क्वायर ऑफ टाइम के प्रोपोर्शनल है. सॉरी ये बोला. अच्छा, यूनिफॉर्म मोशन का मुझे लगा यूनिफॉर्म एक्सेलरेशन का. यूनिफॉर्म मोशन का एक्सटी ग्राफ में ऑब्जेक्ट इज कवरिंग इक्वल डिस्टेंस इन इक्वल टाइम. It covers equal distance in equal time in uniform motion. You can see, and we get a line inclined to time axis, and here the velocity is constant. नहीं आया? जैसे 1 second में अगर 1 meter distance cover किया, फिर 2 seconds में it is covering 2 meter distance. You can choose any interval, any scale of your choice. So it is moving with constant velocity. Every time it is covering equal distance in equal time. It is moving with constant velocity. And for constant velocity, if we draw VT graph, we draw like this. Yes, if the velocity of the object is 1 meter per second every time. So at 0 it is 1, at 1 second it is 1, at 2 seconds it is 1. It is same every time. It is moving with constant. Every time, see here also we are getting constant velocity. You know? So for constant velocity, we have two different graphs. XT graph is drawn like this, VT graph is drawn like this. And for constant acceleration, we have 3 different graphs. We can draw constant acceleration in XT graph like this, in VT graph like this, and in AT graph like this. Okay. जैसा वेरिएबल होगा उसके अकॉर्डिंग आपका ग्राफ का जो स्ट्रक्चर है वो चेंज हो जाएगा, है ना? और कुछ दोबारा कुछ और एक्सप्लेन करना है? यस मुझे नहीं। MCQs based on this. The slope of velocity time curve at any instant of time gives displacement, velocity, acceleration, retardation. Next question. The slope of position time graph gives us the velocity. The slope of distance time graph gives the speed is the correct answer. In relation to a velocity time graph, the curve can be a circle. The area under curve and above the time axis between any two instants gives the average acceleration. The slope at any instant gives the rate of change of acceleration at that instant. The area under the curve and above the time axis gives the displacement. See, we are finding area under curve. बेटा आप देख लो नंबर बार बार उठ रहे हैं. Area under curve find कर रहे हो for VT graph, right? So if you're finding area under curve for VT graph, then it gives the displacement, not acceleration. Acceleration we get by taking slope. Who is that? Okay, now when we differentiate displacement, we get velocity. On differentiating velocity, we get acceleration. So velocity is dx by dt and acceleration is d square x by dt square. Similarly, if we integrate acceleration, we get velocity, and on integrating velocity, we get displacement. Okay, displacement को differentiate करोगे, velocity आएगा, v is dx by dt, है ना? Velocity को differentiate करोगे, dv by dt, you get acceleration. When you integrate acceleration, a dt is v dt. When you integrate it, you get position or displacement. All right. Now we have a question based on this. Find position, velocity, and acceleration at t is equal to 2 seconds. At t is equal to 2 seconds, we have to find the displacement, velocity, and acceleration. Okay. How will you do it? You just have to put the value of t as 2 seconds. So at t is equal to 2 seconds. Because displacement is t cube plus 6t plus 5. So we can find displacement at t is equal to 2 seconds. It's easy. You simply have to put the value of 2 in t to get displacement, right? It's 2 cube plus 6 into 2 plus 5. So 2 cube is 8, 6 2s are 12 plus 5. What will you get? 25 meter. We have done similar kind of question when we had done differentiation. Last or second last question was like this only. है ना? Position was given and we had found out velocity and acceleration. You know how to do it? आता है करना, differentiation आता है. ठीक है, now we will find velocity. Okay, Mudit, now you tell me, how will we find velocity? First we'll differentiate velocity. How do we get velocity? We need to differentiate this position, distance with respect to time, na? Only then we get velocity, है ना? अब क्या करेंगे? d by dt and x, for x we can put t cube plus 6t plus 5. So we'll get 3t square. Which formula we are using here? X and dx. No, it's not integration. No? We are doing differentiation. d by dx of xn.
Power.
It's nxn minus 1. We are using this formula. Okay, so we get 3 t, 3 minus 1 is 2, and 6. 1 minus 1 0 हो जाएगा. No need to write, and constant, on differentiating a constant we get 0. So velocity at t is equal to 2 seconds is, put the value 3 into 2 square plus 6. So you'll get 2 to the 4 3 is 12, 12 plus 6, 18, and it is in meter per second. मेरा नंबर का आंसर सबसे पहले आया. आपने बोला ना 18. Okay, now आप बताओ मुझे, अब नहीं. Acceleration, how will we find acceleration? किसको करोगे differentiate? Velocity को differentiate करेंगे, ठीक बोल रही है ना? Harsh, what do you say?
जो भी आए इक्वेशन उसको आप डिफरेंशिएट कर चेन
dv by dt. नंबर 2 हो गया हमारा स्मार्ट. सबसे पहले आंसर निकालता है, मेरे से भी पहले, इतनी फास्ट. वेरी गुड, आई एम प्राउड ऑफ यू. So velocity is 3t square plus 6. Now differentiate this 3, and on differentiating t square you get 2t, na? 6 is a constant, you'll get 0. So it's 60. So now we'll write acceleration for t is equal to 2. So for t is equal to 2, acceleration is 6 into 2, it is 12. What is the unit? Meter per second square. This is the acceleration, this is the velocity we are getting, and this is the displacement. So these are the answer that we are getting. Okay. Yeah. Next question. फटाफट करते हैं. Find the acceleration of the particle if the displacement of the particle moving in a straight line is given by this, where s is in meters and t is in seconds. S is 2t square plus 2t plus 4. Displacement is in meters and time is in second. And we have to find acceleration of the particle if the displacement is given. Okay, so let's find v first. V is ds by dt. We'll write d by dt. In the bracket, we will write 2t square plus 2t plus 2. What will you get? 4t plus 2. Right? And now we'll write acceleration as dv by dt. Again, differentiate this. No, we're not getting 6.
4 seconds.
6 कैसे आएगा बेटे? 4 into dt by dt करोगे ना? But when you differentiate 2, you get 0. So it's 4. So because distance is in meters and time is in seconds, so acceleration is in meter per second square is the answer. And close your answer in the box. Solve this. Every time you're doing this. Sorry, it's 4. Now I am doing wrong. It's 4 meter per second square. The position x of a particle varies with time as x is equal to a t square minus b t cube. Find the time at which acceleration of the particle becomes 0. So we have to find t. Find t at which acceleration of the particle becomes 0. Okay. So let's find velocity first. Velocity is dx by dt. So it's d by dt. We'll write for displacement. It is minus at square minus bt cube. We are getting on differentiating we get 2at minus 3bt square. Acceleration is, see, a and b are constants. देखते हैं. Again you will differentiate it, है ना? 2at minus 3bt square. What will you get? 2a minus 6bt. So we have to find t at which acceleration becomes 0. So we'll put acceleration as 0. This implies, see, we have 2 to a here. So let's not create confusion. Let's write for acceleration, let's write a dash. For acceleration is a dash, okay? ऐसे confusion हो जाएगा ना? We cannot put same variable for two different things. Same notation use नहीं करते ना हम. You can either use capital A or you can write a dash just to differentiate them, that a dash is acceleration and a is a constant. Okay, so put a dash equals to 0. So 2a minus 6bt is equal to 0. So from here we get t as 2a upon 6b, a upon 3. This is the time at which acceleration becomes 0.